Hello friends, welcome back. And this is Nagaraj SK, lecturer of Computer Science and Engineering Department. So in this video, we'll move to the next lecture, that is lecture number 28 and 29 of Unit 3, Brute Force and Exhaustive Search. So in this session, we'll learn about knapsack problem, how knapsack problem can be, what is knapsack problem and how this can be solved with the help of exhaustive search. So I told you about what is exhaustive search and how the traveling salesman problems can be solved with the help of exhaustive search, right? So in this video we'll learn what is knapsack problem and how it can be solved with the help of exhaustive search. So this knapsack problem is another popular problem which can be solved using exhaustive search. So it can be stated as follows, that is, suppose that there are n objects from I equal to 1, 2, 3 till n. Each object I has some weight wi and values associated with each object is vi and capacity of knapsack is w. So a thief has to pick up the most valuable objects to fill the knapsack to its capacity. For example, uh, a transport plane has to deliver the most valuable set of items to a remote location without exceeding its capacity. This is another example. So here we are considering that uh, weights as w1 w2 wn and values as v1 v2 vn till vn and a knapsack of capacity w, and we have to find the most valuable subset of the items that fit into the knapsack. So how can we solve it, right? So brute force generate all possible subsets of the n items, compute total weight of each subset to identify feasible subsets, and find the subset of the largest value. What is the time efficiency, right? You may ask, what is the time efficiency of this? That is belonging to big omega of 2 raised to n. So the 2 raised to n is the time efficiency of this uh, knapsack problem using exhaustive search. So we have an example here, that is the knapsack uh, weight is that is capacity of the knapsack is 10, and we have the item something like this: item 1, item 2, item 3 and item 4. Item 1 weight is 7 and value of this 7 weight is $42, and item two's weight is 3 and value is $12, and item three's weight is 4, value is $40, and item four's value is weight is 5, then value is $25. So among these, if you we have the capacity of the knapsack is maximum 10, and we have here items one's weight is 7, that we can directly put into the knapsack w, that is having max capacity 10, and item 3 we can put. So the value, by adding these item 1 and item 2, we can get the maximum profit as maximum value of these subsets of items, that is $42 plus $12, that is 54. And if you put this item 3 and item 4, just we have to check which is having the maximum value but least weight. So item 3's weight is 4, that we can put, and item 4's weight is 5, so 4 plus 5 is 9, so we can put it in the knapsack. This item 3 and item 4 we can put, and the profit will become 65. Previous it was 54, now it is 65. So how about taking items in decreasing order of value or weight? So works for this example, right? So what we have to uh, uh, check here is which is the maximum profit uh, of this knapsack. So of these subsets, so 65 is the subset, 3 and 4 we can put, but what are the combinations, what are the subsets we can put? Basically here the list is showing that, here this list is shows that which are the subsets we are adding and what is the weight of them, what is the value of them. So that we are checking here, just a minute. So here are the very first zero subset, zero weight and zero value. Then subset 1 and the weight is 7, the value will be 42. Similarly 2, 3, 4 value is 12, 40, 25. And if you put both, because we have max capacity as 10, so we can put item 1 is having weight as 7, item 2 is having weight as 3. So these first two items you can put, it will become 10, 10 as the weight total capacity, but what is the value of them profit, that is 54. So will that is the 54 is the maximum, so we'll check for other things also. So we have here item 3 and item 4 also, and the combination of item 1, item 3, item 2, item 3, item 1, item 4. Similarly we can check, we can put this item 2, item 3, item 4. No, no, if you put that, the it, it will crosses the limit of the capacity, so we cannot put something like that. So the maximum value we can get here is, that is 65, by putting item 3 and item 4 in the knapsack. So 4 plus 5 is the 9 capacity, so 10 is the max capacity, and the profit of these items is 65. That will be the that will be the feasible value. This one is the, this 65 is the feasible value. So these two items you can put in the knapsack. This is how we are checking, this is how we are solving the problem of knapsack using this approach, exhaustive search approach. So next we'll move to the that, as I said, another example here. So here the maximum capacity of the knapsack is 50, and item 1, item 2, item 3 we have the profit of item 1, item 2, item 3, that is value of those three are like 120, 100 and 60. Then weight of them 30, 20 and 10. So anyhow the capacity of the knapsack is 50, we can put 30 and 20, and 20 and 30 we can put, so value will become 220. So 30 plus 20 is 50, the capacity of the knapsack is 50, then value will become, that is this and this two items we can put here, that this one and this one we can put, and we can get the profit of this item 1 and item 2, that is 100 plus 120, that will become 220. It will become 220. So for other things it will not work. So for other things it will not work. So that's why I'm showing that it doesn't work for this kind of examples. So this is the knapsack problem. So let us summarize. We discussed the only one problem is, that is knapsack problem using exhaustive search. So if you are having any doubts in this, please do ask your queries. Thanks for watching.